now we're going to talk about antiderivatives. We have derivatives. We are talking about antiderivatives. So first I just want to consider. Okay, let's say I have x squared and I want to take the derivative. We're going to get 2x. What if I had f of x equals x squared plus 2 and I take that derivative? We're going to have 2x plus 0, which is just 2x. What if I had f of x equals x squared plus 100? Well, that derivative is going to be 2x. So from here to here, those are the derivatives. Antiderivatives are going the other way. So they go the other way. So if f prime of x is equal to 2x, the antiderivative f of x, so if the derivative is this direction, the antiderivative, or undoing the derivative, is going to be x squared. But all of these antiderivatives, all of these derivatives, that's an antiderivative, that's an antiderivative, that's an antiderivative. So that constant, we don't know. So we're going to call that C. So this is what we call the general equation. Okay. If you think about the graphs, if I have x squared, it looks like that. X squared plus 2 is just going to be moved up 2. Plus 100 is going to be up here. So the slopes of all of those graphs are the same. The constant doesn't affect the slope at any point. It just has the location. The f of x, say f of x was x squared plus the 2, or f of x was x squared plus 100. These are called the particular equations. Okay, so we're going to find the general equation for the antiderivative. Another name for this is called an indefinite integral. Okay, so antiderivative and indefinite integral are the same thing. So for right now, because we haven't gotten to integrals yet. Integrals are the other half of calculus. We've got derivatives and integrals. We'll just call it the antiderivative. We are undoing the derivative. So this is, I always liken this to foiling and factoring. When you foil's easy. You have a rule for it, you distribute. Factoring, undoing that, is a little bit trickier to think about. So right now we have some things that we are going to underive. So if f prime of x equals 4x cubed, f of x, well, think about what would I take the derivative of that would result in this? Well, that's just going to be x to the fourth. If I take this derivative, we get 4x cubed, but there could be that constant. So that plus c is going to be a feature of any general equation. Okay, what would give me 9x to the 8th? Well, that's going to be just x to the 9th plus c. And just like with foiling and factoring, it's easy to check our work, because if I take this derivative, I'd end up with 9x to the 8th plus 0, which would give me that there. Okay, x cubed. Okay, I'm going to leave a little space here. And I know that if my result has an x cubed, that my original function is x to the fourth. But if I take this derivative, I'm going to end up with 4x cubed. So to undo that, I'm going to multiply by a 1/4, because now if I take this derivative, multiply that down, we have 4 over 4, which is 1, x cubed. So when we are taking the derivatives, we multiply by the power and subtract 1. When we undo the derivatives, the antiderivatives, we're going to add 1 to the power and divide by whatever that new power is. So this one here is going to be 1/11th x to the 11. Okay, 1 over 11, x to the 11 plus c, because if I take that derivative, the 11 cancels out, and we end up with 1 there. This one, we know what function gives us this as a derivative. That's just going to be the square root of x plus c. Here, f of x equals, I'm going to leave a space again because I know I'm going to have some constant, but it might not be totally obvious. Okay, when we do the derivative, we subtract from the exponent. When we do the antiderivative, we're going to add. So I'm going to add 1. So that's going to give me a -2, but there's no coefficient here. So I have to deal with that by multiplying that by a -1/2 or a 1 over a -2. And again, you can check your work. -2 times -1/2 is 1, and then we'd subtract 1 to get that cubed. All right, our next one, x to the 5/2. So I'm going to leave some space for my coefficient. So I'm going to add 1 to 5/2. So that's going to be 7/2. And then in order to make the coefficient here 1, I'm going to multiply by 2/7 or divide by 7/2. If I take this derivative, that would be my result. Plus c. Here, we're going to have, I'm going to just put the 24 times, I'm going to leave a space. X, I'm going to add 1, so 5/3 plus 1 is going to be 8/3. To get rid of that, I'm going to multiply by 3/8, so when I take the derivative, that would cancel. And then I can simplify this. So 24 divided by 8, so that's 3 times 3 is 9. X to the 8/3 plus c. Okay, the antiderivative of cosine. So what would we take the derivative of that results in cosine? Well, that would be sine. Take the derivative of sine is cosine. Okay, the derivative, what would give me a sine? Well, the derivative of cosine is negative sine. So the antiderivative of sine is going to be a negative cosine. We can use that here. This one we have to think of undoing the chain rule, because if I were to take this derivative, we'd have cosine 3x times 3. So we're undoing that. Okay, so starting with what would give me a cosine, well, that's going to be a negative, or what would give me a sine is a negative cosine, 3x. But again, if I take this derivative, we'd have a times 3. So we're going to have to undo that by multiplying by 1/3. So you could rewrite this as negative 1/3 cosine 3x. But again, you can always double check your work, plus c, by taking this derivative. If I take this derivative, that should be my result. Okay, similar thing here. So I'm just going to build from here. So I know we're going to have 4x plus 3. We're going to add 1 to the power, so that's 7. To undo that 7, I need to multiply by 1/7, because if I take the derivative, there's no coefficient here. But then I need to deal with this 4, so I'm also going to multiply by 1/4, because if I take this derivative, this is what I want as a result. But if I took just this derivative, we'd have a 7 out front, and we'd have a 4 that we'd be multiplying by. So I need to undo those things here. So this is 1/28 4x plus 3 to the 7th is our antiderivative. And these take practice. This is just, like I said, like factoring. Foiling's easy. There's a rule, you do it, you're done. Derivatives are easy. There's a rule, you do it, and you're done. Antiderivatives take a little bit more thinking. This one, it's just going to be each one added up. So if f prime is this, f is going to be 1/3 x cubed minus 3 halves x squared plus 9x plus c. Now we're going to go ahead and find the particular solution. So that plus c is actually going to have a value. So if my derivative is 2x plus 2, my antiderivative is going to be x squared plus 2x plus c. Okay, now I have more information. I know that f of 1 is 5. So we're going to plug that information in. So my function value is 5 when my x is 1. And then we just use our simple algebra. So we're going to subtract 3. So my c is 2. So my particular solution is x squared plus 2x plus 2. Okay, if f prime of x is negative sine plus cosine, what is the particular solution if f of 0 is 2? So we'll first take our antiderivative. So antiderivative of negative sine is cosine of x, because if I take the derivative of cosine, we get that. Antiderivative of cosine is going to be sine plus c. Now we'll plug in our information. So 2 is equal to cosine of 0 plus sine of 0 plus c. Cosine of 0 is 1. Sine of 0 is 0 plus c. So I'll subtract that 1. So my c is 1. So my particular solution is cosine of x plus sine of x plus 1. Okay, let's deal with this guy. So f of x is going to equal, we're going to have that 8 times, I'm going to leave some space here, so I know I'm going to be adding 1 to the exponent. So 2x plus 3 to the 4th. I need to deal with that, so I'm going to multiply by 1/4. So when I take the derivative, it's not there. And then we'd have to multiply by 2 if we were taking the derivative. So I need to undo that. So f of x, this 8 is going to be divided by 8. So we're just left with 2x plus 3 to the 4th. Now I'm going to plug in 0. So 85 is going to equal 2 times 0 plus 3 to the 4th. Sorry, plus c, plus c. We're finding c. So if I plug this in, 2 times 0 is 0, 3 to the 4th is 81. So my c is going to be 4. So my particular solution is going to be 2x plus 3 to the 4th plus 4. So now we're going to talk about the relationship between displacement, velocity, and acceleration. So displacement, velocity is the change in position over the change in time. So if I take the derivative of displacement is going to be velocity. The derivative of velocity is acceleration. So to go from displacement to velocity to acceleration, we're going to take the derivative. to go the other direction, if I have acceleration and I want to find velocity, or I have velocity and I want to find displacement, we're going to use the antiderivative. Okay, so our next example, Ray Singh accelerates to pass a truck. His velocity is given by v of t equals 50 plus t to the 0.6, where v of t is in feet per second and t is the number of seconds since he started accelerating. Let d of t be Ray's displacement from a speed limit sign on the highway. Write an equation for Ray's displacement from the stop sign at any time t if his displacement is 100 feet when t is 0. So we're going to find the antiderivative of this. So this is going to be 50t plus, I'm going to add 1 to the 0.6, so that's going to be 1.6, and then I'm going to divide by that value, plus our constant. And for that, our particular solution, our displacement is 100 when my t is 0. So that's 0, which means c is 100. So my equation for displacement is going to be 50t plus 1 over 1.6, and you could simplify that if you want, t to the 1.6 plus 100. Write an equation for his acceleration. That's going to be the derivative of velocity. So we're going to take the derivative of this. So the derivative of 50 is 0. The derivative of that is going to be 0.6t. And then we're going to subtract 1 because we're taking the derivative and not the antiderivative. So if we subtract 1, you're going to have negative 0.4. We have a multiple choice question here. So if dy dx equals this, then y equals one of these two things. Now option number 1 is to take all of these derivatives and see which ones match, or you're taking the antiderivative. So the antiderivative of cosine is going to be sine. So if I took the derivative of sine 2x, I'd get cosine 2x times 2. So we're going to have that 1/2 to undo that, and then plus the c. So we're looking for which one matches, and that's going to be c.